Hi, this is Scott Allen, and this module is an introduction to ASP.NET MVC 4. This module will give you an overview of what is new in ASP.NET MVC 4. If you've never worked with ASP.NET MVC before, I'll be building a simple application to demonstrate the basics of the framework. But even if you have worked with ASP.NET MVC previously, the demo will show off some of the new features for version 4. Let's look at the release notes for MVC 4. If you go to the ASP.NET website, you'll find some release notes for MVC 4 that list the new features for this version, as well as how to install the framework and update existing applications. One of the new features for version 4 is the ASP.NET Web Api. This is a framework for building web services that embrace HTTP. I have a module dedicated to the Web API in this course, and John Flanders also has an excellent course dedicated to this topic. The mobile features of MVC 4, including the mobile project template and display modes, these are covered in the mobile module for this course, and if you're interested in more information on jQuery Mobile itself, I also have a course dedicated to that topic. The task support for asynchronous controllers is the focus of the async module in this course. Asynchronous controllers allow you to keep an application scalable even when you have a lot of long-running network calls to make from your controllers. And the bundling and minification features allow you to optimize your JavaScript files and CSS style sheets for download. We'll take a look at the bundling and minification features of MVC 4 in the optimization module. Finally, this module will cover just about everything else. We'll build a small application from scratch and see how to use database migrations, how to deploy to the cloud, talk about the MVC design pattern and see how controllers, views, and models all work together. And I'll also talk about some of the enhancements to the default project templates. From here on out, we'll be using Visual Studio 2012 to build a web application, although you can do everything I'm going to do with Visual Studio 2010 also, because ASP.NET MVC 4 will happily install itself into Visual Studio 2010, and there's nothing special I'll do with 2012. The application I want to build will be a simple application to manage the employees of a company. Every employee will be in a department, and I at least want the ability to list and add employees to a department. I'm going to primarily focus on the mechanics of ASP.NET MVC, and I won't go into any details on ancillary topics like unit testing. But I will point you to some resources on those topics when we get to certain points, because Pluralsight does have a vast library that covers everything else like unit testing, design patterns, and AJAX. One way to get started with ASP.NET MVC 4 after you install it is just to say File, New Project, select the ASP.NET MVC 4 Web Application Project template, give it a name, click OK, and you're off and running. I'm going to do something slightly different just to show you what the possibilities are. And under Other Project Types, Visual Studio Solutions, I want to start with a blank solution actually. And I'm going to call this Solution eManager, or Employee Manager, Electronic Manager, however you want to think of it. And now if I open the Solution Explorer window, I have a solution, there's no projects inside yet. Instead of starting with an ASP.NET MVC project, let's get started with a project that represents the entities and the business objects that I care about. So I will put those inside of a Windows class library, which produces a DLL which you can reference from other projects. And I'll call this emanager.domain or emanager.core. The idea is to have a project here, an assembly that I can reference that just has some C# code inside of it for the objects that I really care about, things like employees and departments. Once this project is ready to go, we'll add some code in here to represent employees and departments. Let me delete class1.cs that comes here automatically, and let's instead add a new class called employee. I want employee to be a public class, and every employee is going to have an identifier, an integer ID. Every employee is going to have a name. Of course, we could also have first name and last name, but I'm just going to stick with name for now. And I think that's enough to get started with, actually. Let me also add a class to represent a department. And every department, this will also be a public class, is also going to have an identifier, is also going to have a name, and it is also going to have a collection of employees. So you can have 0 or more employees inside of any given department. And before I forget, let me also add one more thing. I'm going to hold down the Alt key and make a selection across 3 different rows and then start typing. That's a feature that's been available in Visual Studio since 2010 that allows you to do a columnar selection. And I'm going to add that to employee also. And the reason I'm doing this is because the entity framework can do very efficient change tracking and add additional features to an object if you make your properties virtual. We'll see that in a bit. And now let me add one more type inside of here. I want something that represents a data source. So maybe I could call this department data source. And I'm going to put this inside of this assembly, this project, because it's really just an abstract interface definition that represents how you would get to employee and department information. Add properties of type iQueryable to this. That's something that you can query with LINQ. These don't need to be public in an interface definition, but I want a queryable set of employees. I want a queryable set of departments. And we really just need getters on here. We don't need setters. You just need to be able to get to employees, get to department. And chances are we'll need to come back and change some of these definitions later, but that's okay. Let's find out where we are first. We have departments, we have employees, we have a data source or an abstraction for the data source to get to the information about employees and departments. Now let me come in and add a new project. This one is going to be an ASP.NET MVC4 web application, and we can call this one eManager.web. When you create a new MVC4 application, you have your choice of templates that you can use to create that application. The empty template gives you a web application that really doesn't have much of anything inside of it. There's no scripts, there's no style sheets, there's no default views. So if you know exactly where you want to go with the project, the empty template might be for you. I'm going to select the Intranet Application template. The Intranet Application automatically comes with a home page and a layout view and some scripts and style sheets. It has an account controller that allows users to sign in, allows users to register for your website. An Intranet Application assumes you're going to publish this somewhere on the internet. The Intranet Application offers many of the same features as the Internet Application, but Intranet assumes you're inside of a firewall, you have Active Directory available, and your users will primarily come into your application as authenticated Windows users. There's also the Mobile Application Project template, which we'll talk about in the mobile module of this course, and the Web API template, which we can talk about in the Web API module. So I will create Internet Application and select OK. Again, we won't be talking about unit testing. If you want to see more information about unit testing, there are a couple great unit testing modules and courses out there on pluralsight.com. David Starr has done some of that work. I've done some of that work. I also cover unit testing in an MVC application in my MVC3 course. Everything in that course still applies to this course. And also I touch on it in my LINQ architecture course, which talks a lot about how to build abstractions that make for a testable application. So you can see that project took a little while to create. And one of the reasons is this. If you've done any work with MVC in the past, you might be aware that the MVC project templates add a lot of things into your project, like the jQuery library and other libraries and assemblies. If you ever needed to go through and update jQuery, then you had to go out to a website and download jQuery and copy the library into your project. With MVC4, things are a little bit different. If you're familiar with NuGet, and again, that's another topic that we have available as a course here on Pluralsight, NuGet is an extension for Visual Studio that can help you manage dependencies and libraries inside of a project. And one of the files that NuGet will leave behind is a packages.config file that tells you everything that's installed into an application. And here we can see libraries, JavaScript libraries like Modernizer are installed. Libraries like the Entity Framework here are referenced as a NuGet package and not just a plain reference, because that makes it very easy to update any of these components. I can go into Manage NuGet Packages after I right-click on References. I can see what updates are available. And for example, if I wanted to update jQuery, hopefully jQuery will appear as an update here in the list of potentially updated NuGet packages. There we go. I can update jQuery, jQuery validation, jQuery UI. I can update all these libraries really easily because they've been installed as NuGet packages with MVC4. But let me close this and just run the application to make sure we have something that is working. So I will set emanager.web as the startup project. Hit Control F5 to run without the debugger attached. And this is our new MVC4 application. Let's talk about some of the structure behind this. Here's how the home page before you works. ASP NET MVC is a UI technology based on the model, view, controller design pattern. In the MVC pattern, you separate your UI code into distinct components. You have models, you have views, and you have controllers. The models contain the data to display and some associated logic. The controllers are responsible for receiving a request and figuring out what to do. They often build a model, and then they select a view to display that model. The view then is responsible only for taking the model from the controller and producing the HTML that you see in the browser. Each component has distinct responsibilities in MVC, so you don't have all the code jumbled together and becoming difficult to work with. When I make a request from this browser, like to localhost 9027, the runtime will go looking for a controller to process this request. And in MVC, that is part of the routing logic. Routing is something that's configured during the start of an application. And in ASP.NET, that means it happens inside of a special method named application start that lives in a special file called global.asax.cs. There's all sorts of configuration happening in here, but it's broken out into different classes. There's bundling configuration, which we'll talk about in the optimization module, and filtering configuration and routing configuration. There's a call to a method called register routes. This class, route config, and its method, register routes, lives in a folder app_start. Inside of here, you'll see all sorts of configuration classes, and this is a little bit different than what it was in MVC3, where we had all of the configuration jammed into the global.asax.cs file. Now all of that configuration code is inside of classes that are in the app start folder, and we just call into them during the application start event. Let me open up the route config file, and we can see that there are two routes inside of here that are defined. One is for Web API controllers. We'll talk about that in another module. And then there's the route known as the default route. What a route specifies is a pattern for the runtime to match against an incoming URL. So if a request arrives for what you see in this comment here, /department/detail/3, the runtime knows to pick that apart and to go looking for the department controller and then invoke the detail action on that controller. We'll talk about actions here in just a bit, and possibly pass along an identifier as 3. So pass along a piece of data to that controller action that tells it, hey, the ID you're looking for is 3. There's also some defaults specified for each route. So if a part of this URL is missing, the MVC runtime can substitute values. For example, if the ID didn't exist here and we just had a request for /department/detail, that's okay. The ID is optional. It might show up as null in our controller action. If we don't specify an action in the URL, then the controller knows that it just needs to go looking for the department controller, but then the default action is index. So invoke the index action on the department controller. And if a request arrives for the root of the application, we have enough defaults to plug in values for everything there too. The controller will be the home controller, the action will be the index action, and the ID is still optional. And what that means is if I go back to the browser where this is running, I can make a request to /home, that arrives at the home page, and I can make a request to /index, and that arrives at the same page, and that's all because the defaults were /home/index. If I try to go somewhere that doesn't exist, like /foo, and there is no foo controller, I get back an HTTP 404 message. That could also happen if I look at the controller. So all of the controllers for ASP.NET MVC are in the controllers folder by default. They don't have to live here. You can put them in any folder. You can even put them in a different project. But if I open this up and comment out the home controller and then do a build, the home controller no longer exists. So if I refresh /home/index, we should also get a 404 message. Doesn't exist. Essentially, that's the runtime telling you that it cannot find something to process this request. Let me show you a little more about how this works. Let's say we did want to respond to a request for /home/sayhello. Currently, of course, that returns a 404 error. That means I would need a home controller. So let's flip back into our homecontroller.cs file and write a public class that is the home controller. So literally, the controller name starts with the word home, and it needs to derive from a base class provided by ASP.NET MVC, the controller base class. There's also an interface at a very low level you can derive from, but the controller base class is good enough for what we want to do. Now the action part of the URL, say hello, gets parsed into the action. That will literally be a method name that the runtime goes and looks for. So I could create a say hello method, in other words, a say hello action. And just by having that in place, if I do a build and I refresh the browser, we should no longer get a 404 error, but we get a blank page because that say hello action isn't doing anything. I could have the say hello action do something like return a string, just return a string, hello world. A little bit off on the capitalization, but that's okay. If I do a build now and refresh, I should see the text say hello. And there's no HTML involved, there's no JavaScript, CSS. It's literally all we sent back from the server is just the text hello world that shows up in the browser just fine. But what you typically do in a controller is you put together some sort of model by querying a database or querying something on the file system, putting together a model and handing it off to a view. At this point in time, we're not dealing with any models just yet. I've uncommented the home controller. You can see all we do in the index action is just set a message in this property called viewBag and say return view. ViewBag is one way to tunnel information from a controller into a view. Every view has access to viewBag. It can pull out things like the message. We'll see that in just a second. Return view is just a fancy way of saying the next thing that I want to do is I want you, dear MVC runtime, to render a view for me. But which view? It's going to be what we call the conventional view for this particular controller action. In every ASP.NET MVC project, you will have a views folder. By default, that is where your views live. If you have a home controller, then the default view for the index action of the home controller will be a view that lives in the home folder under views, and it's called index. So you can see there's a naming convention in play. If I were to rename this as index 2 or index 3, the MVC runtime wouldn't be able to find it unless I went in and explicitly told it, well, the view that you should use is index 3. But in this case, I'm really just want the default view, which is the index view. I could specify it explicitly there. By putting everything back together like this, we should be able to get the home page that we saw earlier again. Of course, I need to remove the say hello part so that we go to the index action. And there's our home page. Let's look at this view. This view, under the views folder, consists of most of the HTML that you see there on the screen, and you can see that it includes a viewBag title, viewBag message. The title was actually set up here. This is a Razor view. It has a CSHTML extension. Razor views are just a way to intermingle HTML markup and C# code. Wherever you see an @ sign, that is usually the beginning of a C# expression. Of course, you can also have literal @ signs. If you escape it, that would be displaying @viewbag.title literally in the browser, but we want it to display the result of evaluating the C# expression, which is to display viewbag.title. You can see it's really quite clever about knowing when you have C# code and then transitioning back into markup mode. In fact, viewbag.title this extra dot here would normally be a compiler error if that was in a C# file. But in Razor, it's smart enough to figure out that, well, that doesn't make sense as an expression. You must literally want to display a period here after the title. So Razor's pretty sharp about that. And you might be wondering, well, all of the HTML that I see here is not entirely indicative of what I'm seeing on the home page. For instance, there's no register link, there's no login link. Where does all that stuff come from? That comes from a layout template that is also a Razor view that's part of this MVC application by default, and that is in the shared folder. Any view that you put in the shared folder is available to all controllers anywhere, and this is typically where you find the layout view. It's the layout view that defines the head tag, the body tag, it's the layout view that is rendering those links in the menu at the top of the page, the home link, the about link, the contact link, and it is the place where you call render body in this view where index.cshtml will appear. When your home controller says render the index view, then everything that you see inside of here that's not in a section will be rendered when the layout view calls render body. The sections will be rendered at the point where that particular section is rendered in the layout view. So when this says, please render the section called featured, then in the index view there will be a section featured that contains the markup that gets placed at that location. Ultimately, what I'd like to do is to display a list of departments on this home page to allow users to start viewing departments and adding employees to departments. So let's just call this the Department Manager page, and I'm going to delete all of the other markup that was inside of here. And if I refresh the browser, we should see those changes reflected here. Now my index view just shows the markup Department Manager. Everything else that you see here, the copyright, the obligatory link to Facebook and Twitter, those are all part of the layout view. I could go into the layout view and change that stuff too. But now you've seen that we have a controller that responds to /home/index, or just /home, or just / to the root of the URL. It's not putting together a model yet. We don't need this viewbag.message anymore. And it's rendering what we call the conventional view, which is the view that has the same name as this action on the controller. So the index action of the home controller. And what I'd like to do next is have this index action get a list of all the departments that are going to be in my database and hand that off to the view so that the view can display the departments in a list here. And to do that, we'll need to get set up with a database. I want to store employee and department information inside of a SQL Server database, and to access SQL Server, I'll be using the Entity Framework version 5. If I look at the list of installed packages in a brand new ASP.NET MVC4 Intranet application, I will see Entity Framework was added to this project by default. This is version 5 of the Entity Framework, currently in pre-release, but that should be finalized soon. And I want to access the SQL Server through the Entity Framework using this abstraction that I defined earlier, iDepartment Data Source. That will give me access to employees and will give me access to departments. And I just noticed that this property name is wrong. I shouldn't be naming this type. I should be naming this employees. So I'll make that quick correction and do a build to make sure everything compiles. And then, since I need this interface definition in my web project, I will add a reference to that project. So right-click, add reference, go to the reference manager, select emanager.domain, click OK, and now emanager domain is a reference in my web application. And that means I should have access to that type. Let me create a folder in the web application called infrastructure. This is where I will put all of the real data access code that talks to SQL Server through the Entity Framework. And it's inside of here where I will add a class, and let's call it Department DB. I want Department DB to be derived from an Entity Framework base class called DB Context that takes care of all the data access stuff that I need. I never have to worry about a SQL connection or SQL parameter or anything like that. And I also want it to implement the iDepartment data source interface that I defined earlier. because I don't want my controllers to know about department DB directly. I want them to do data access through this interface definition. That just makes the controllers a little more testable. We're not going to go into the unit tests in this module, but also makes them a little more decoupled and flexible. For the entity framework to access my employee information, I will need to define properties of type dbSet. dbSet is a type defined by the entity framework. It basically derives from iQueryable and iEnumerable ultimately, but we'll have those there so the entity framework can get to employees and departments. dbSet also provides functionality for adding and removing employees and departments. The next thing I'll do is implement this iDepartment data source interface because it defined employees and departments also, but it defined them as type iQueryable of employee. What I can do is I can tell Visual Studio to explicitly implement this interface. That gives me a version of employees that returns iQueryable, that satisfies the contract for iDepartment data source. And when someone calls the employees property through that interface definition, I can just return employees the dbSet type. And let's do that for employees. Let's do that for departments. And believe it or not, this is almost everything that I need to be able to start accessing SQL Server. In fact, this is just about everything that I need to create a database in SQL Server, because the Entity Framework version 5 has what we call code-based migrations, where it can simply look at your DB context class, see what DB sets are available, look at the definition of employee, look at the definition of department, and generate a SQL Server schema from those type definitions. Let me show you how that works. I'm going to open up the Package Manager console, so the NuGet Package Manager console, make sure my web project is selected, and tell the Entity Framework that I want to enable migrations in this project. What this will do is create a migrations folder for me in Solution Explorer and add a class called configuration.cs. That's what we see on the screen here. And I'm going to enable a feature known as automatic migrations. Automatic migrations are great when you're a solo developer or working on a small team or just getting started on a project. Essentially what they allow you to do is quickly make changes to your database and keep it in sync with what is in your code without adding any additional code into your solution. If you're in a situation where you need a little more process or you have a DBA involved, you might not be able to use automatic migrations, but they're going to suit our purposes just great. I'll show you how the migrations work here in just a second, but I'll also tell you right now that when a migration runs, that is when you create a database from your C# type definitions, or you change your C# classes and you need to make schema adjustments to accommodate those changes, there is a seed method on this configuration class that can run each and every time that happens. And seed allows you to initially populate the database with some information. So every application typically has some sort of lookup table or multiple lookup tables that contain static data, things like a list of countries or a list of postal codes. It's the seed method where you can make sure your database is initially set up with that information. And let's say that I initially want to seed the database with some departments just to make sure they're in there right from the very beginning. Then I can say context.departments.add or update. This is a method that you really only use during the seeding phase of a migration. It tells the Entity Framework, take this department and either add it immediately, or if it already exists, then update it. Since we do not know what the ID of a department is at this point, SQL Server is going to manage those IDs. Then I can tell the Entity Framework to look at the name property of a department, and if it doesn't find that name, then add a department. If it does find the name, then update it. So let's create some departments. I want a department for engineering. I want a department, I guess we could have a sales department. If we have sales, then maybe we also need a shipping department. And of course, every company needs the good old human resources department. So now, every time I make a change to the database, a schema change to the database, or create a database with the Entity Framework, it should make sure that those 4 departments exist in the database. Let's create the database. I'll go back to the Package Manager console. And now I can type update database. And you might say, well, which database? Well, the Entity Framework will use some conventions to go out, and if it doesn't find a database by a particular name, it's just going to create it. And you can see here that it automatically applied a migration to it. That migration should have had all the DDL statements needed to create tables and foreign key relationships and primary keys to store my departments and my employees. And where does it go? By default, in Visual Studio 2010, it would look for SQL Server Express running. And it would just go up to SQL Express on the local machine and create a database that has the same name as your DB context derived class. So if my DB context derived class is called Department DB, I should find that database in SQL Express. In Visual Studio 2012, it's a very similar story, but by default, the Entity Framework will use LocalDB. LocalDB is the new version of SQL Express, and it will place the database in a folder called App Data. I'll go here in Solution Explorer and say, show me all files. Now I can see that there's a Department DB database in this folder, so that matches the name, including the namespace of my DB context derived class. I can actually double click that to open it up in Server Explorer. And if I go into tables, I can see there's departments and there's employees. My employees have an ID column, a name column, a department ID, foreign key column. All of that was just created based on my C# type definitions. The Entity Framework looked at them, figured out what sort of database it would need to store that information. Now, if I want a little more control over where this database is created, what server it's going to, what the name of the database is, I can just tell the Entity Framework to use a particular connection string. And that's actually something I'm going to do right now. I'm going to delete this database. Make sure that it's removed from App Data. And then in my Department DB class, I'm going to add a constructor. When it calls the base class constructor of DB context, one of the parameters I can pass here is an explicit connection string or the name of a connection string. So I'm going to tell it to use default connection. Because if I look in web.config, a default connection has already been created for me by the new MVC4 project template. Default connection in Visual Studio 2012 will just go to localDB. It will create a database called emanager.web. In fact, let's fix this up a little bit. So it's just emanager.web is the database name in a file that is the data directory. And I can also modify this name also. I could say this should be emanager.mdf. And I wanted to make all these changes because this default connection string is going to be used both by me and my Department DB to access employees and departments. But later, we will add the ability to let a user log in and register and restrict some of these features to only admins. I want that membership and role information to also be stored in the same database. And ASP.NET has features that will automatically do that for me, but they will need to know the name of a connection string to reach a database. So now everything is in place. Or if I do a build, we're still building. And if I open up the package manager again, I should be able to come out and do an update database. And this time, let me add the -verbose flag, and that will show you all of the commands that are being sent to SQL Server. So you can see there are indexes being created, tables being added, and also a table called Migration History that will contain all of the information about migrations that have operated on this database. And with that in place, let's go into App Data again, and let's show all files and do a refresh to see we now have emanager.mdf, just like I specified in the connection string. And if I open that up, again, we have departments, we have employees. Employees have all the right properties. I can show the data that's in the department table, and hopefully we'll find our 4 departments that we created during the seed method. And there we have engineering, sales, shipping, and human resources. Great. Now let's see if we can get that information into a browser. Now that I have my database set up, I want the home controller to be able to get a list of all the departments in that database and hand it off to a view to render. The simplest possible way to do that would be in the index action of my home controller, look at the department property of an iDepartment data source, that's all the departments that are available, and simply take that value and pass it off to the view. There's another overload of the view method where you pass in the model for the view to render. At that point, the view should be able to grab that object, loop through the departments, and build some HTML so the user can see all of the departments that are in the database. The one catch here is that initially I wanted the controller to only know about iDepartment data source. That makes things a little more testable and a little more flexible. But right now it is explicitly creating an iDepartment data source by instantiating a department DB. That's the class that we just derived from DB context that uses the entity framework. This is easy enough to fix up. If I truly just want the home controller to only know about iDepartment data source, then I would remove that hard-coded dependency and define a constructor where I say, if you're going to create me, what you need to do is pass in the iDepartment data source that you want me to use, and I'll assign that to a private field. Now my home controller knows nothing about department DBs. The one hitch to this is if I hit Control F5 to build and run this application, is that the MVC runtime doesn't know how to create a controller that doesn't have a default constructor. A default constructor is a constructor that doesn't have any parameters. It's parameterless. That, fortunately, is a very easy problem to fix. What I just need to do is plug in some additional components into the MVC runtime that can create that controller for me. And there's several of these components out there. They're typically known as inversion of control containers. There's one called Ninject. Microsoft has one called Unity. I'm going to go out and look for one called Structure Map, and I'm going to look for the MVC3 version of Structure Map. It still works with MVC4, they just haven't updated the explicit name here to say MVC4. I'm going to select that particular NuGet package, say please install this. That's going to add some code-based configuration files and assembly references into my project. I just need to find one particular file that should be under the dependency resolution folder. It's called ioc.cs, and this basically configures Structure Map. I'm not going to spend a lot of time on dependency injection or what this is actually doing, but if you look at this code, what I'm going to say is that when you see something that needs an iDepartment data source, then the concrete type that I want you to put into that component is a department DB, that type. And now Structure Map plugs into the ASP.NET MVC runtime. When the MVC runtime sees that it needs to create home controller, it relies on Structure Map. It says, dear Structure Map, do you know how to create one of these? And Structure Map will look at this and say, oh, I need to call this controller, but I need something that implements this interface. Fortunately, someone has configured department DB to be used as an iDepartment data source. So I'll just create that controller for you, pass along this object, and everything will work just fine. The only other thing that I'm going to add here is a method that tells Structure Map to scope this to a particular HTTP request. And now I have everything for this to work except for the view. At this point, we have a view, but it doesn't know anything about departments. And instead of using this existing view, let me show you a quick way to do this. I can right-click inside of this method and say add a view, and I'll get this add view dialog that can create things for me pretty quickly. This is what we call scaffolding in ASP.NET MVC. It's the scaffolding that builds out things for you. I can say I want a strongly typed view. That is a view that knows what type of model is being passed into it. I can say that the model I'm passing in is a department. Actually, it's a list of departments. So please scaffold out a view for me that uses my default layout page that would display a list of departments. And if I click add, I'll get some HTML markup and razor instructions to dump out a list of departments. Here's a for each item in that model. Give me a display for the item name, and then provide some links. I'll hit Control F5 to run, with structure map in place and our SQL Server set up, we'll hopefully get a quick list of departments. And there's our departments: engineering, sales, shipping, and human resources. So I scaffolded that view out. You don't need to use scaffolding, and you can always come in here and modify things. In fact, let me just start this over. I want the title of this page to be all departments. And in fact, I will have an H1 tag here that outputs viewbag.title. And I can do that with one of the Razor C# expressions just by including at the front. And then I'm going to create an unordered list of these departments instead of a table, which is what the scaffolded code gave me. And I can say for each department in the model, there's a model directive at the top of this view that tells Razor exactly what type of model should be passed into it. So it should be expecting an IEnumerable of department. That means I can loop through the model and get a department out for each object. For each object, I'll create a list item that just has the department.name. Let's save that and see what this looks like. And there we have all departments again: engineering, sales, shipping, and human resources. To review what we've seen so far, we have created a new MVC4 Intranet application, and I showed you how routes take requests from a browser and send them to a controller. Here we are requesting /home/index, and that goes to the index method on the home controller here inside of my application. It's a simple naming convention. The home controller ultimately uses a class derived from dbContext, which is a part of the entity framework, to talk to SQL Server. The controller doesn't know we're talking to a dbContext derived class, though, thanks to the constructor here. The only thing we know about is an iDepartment data source inside of the controller. Behind the scenes, there is the entity framework, which we not only use to access the database, but we also use the entity framework migrations in the entity framework version 5 to create our database. You can see the controller uses the iDepartment data source to grab all the departments. It hands off the departments to the view to use by passing the departments into the view method. The view we are using is the index view. That's the default view for the index action. And this view takes the model and creates HTML. Using some C# code, we loop through the model and write out the department names. If you want more details on controllers and views and Razor syntax, my MVC3 courses go into much greater detail, and everything I cover in those courses is applicable to MVC4. In the next module, we'll continue with this demo by adding more controllers, more views. We'll see how to create links in our views, how to edit and update data and perform data validation. We'll also authenticate users and then deploy our application to the internet, but not just the internet, to the cloud.